Three types of chemical reagents are used during the froth flotation process: collectors and promoters, frothers, and modifiers. Collectors and promoters are adsorbed in the surface of the solid as very thin films. Due to their properties, they are able to increase the contact angle between the solid and the gas. Promoters are agents forming films 1 molecule thick. They give the surface the characteristic of a hydrocarbon which is not wetted by water. This kind of reagent uses 0.05 to 0.15 pound per ton of solids treated. Collectors are surface active agents that are added to the flotation pulp. They produce films several molecules thick. As much as 1 pound per ton of solids treated may be used with this reagent. Also, the longer the nonpolar or hydrocarbon part of the molecule, the greater the contact angle. They are classified as either non-ionizing or ionizing. The non-ionizing collectors are practically insoluble in water. By covering the particles with a thin film, these particles tend to be hydrophobic. The ionizing collectors dissociate into ions in water and are made up of complex heteropolar molecules, in that the molecule contains both a nonpolar hydrocarbon group with pronounced hydrophobic properties and a polar group with hydrophilic properties. They adsorb either physically or chemically on the particle surface and can further be classified into anionic or cationic collectors depending on the nature of the nonpolar hydrocarbon group. Common examples of the ionizing collectors include fatty acids, long-chain sulfates, sulfonates and amines, xanthates, and dithiophosphates. Frothing agents prevent coalescence of air bubbles at the surface of the water. They are also surface active agents added to the flotation pulp primarily to stabilize the air bubbles for effective particle bubble attachment, carryover of particle-laden bubbles to the froth, and removal of the froth. Moreover, they are mainly responsible for maintaining the froth. Around 0.05 to 0.3 pound of frothing agent is used for 1 ton of solids. The reagent must also both be sparingly soluble in water without appreciable ionization, and can be adsorbed between water and air interface to reduce the surface tension of water. And lastly, modifying agents. These are used to activate or depress the adsorption of the filming agent. Modifiers react with the surface of the solid to change the character of its surface, and they prevent the adsorption of the collector or promoter to the solid. For these kinds of reagents, the acidity or pH of water is an important factor in controlling and modifying the ease of filming, and in some cases, flotation is only possible for a certain range of pH levels. Modifiers are further classified into several classes of chemicals, each with its own purpose. Perry classified them as follows. Activators are used to make a mineral surface amenable to collector coating. Copper ion is used, for example, to activate sphalerite, rendering the sphalerite surface capable of absorbing a xanthate or dithiaphosphate collector. pH regulators such as lime, caustic soda, soda ash, and sulfuric acid are used to control or adjust pH, a very critical factor in many flotation separations. The presence assists in selectivity or stop unwanted minerals from floating. Typical are sodium or calcium cyanide to depress pyrite while floating galena. Dispersants and flocculants are important for the control of slimes that sometimes interfere with the selectivity and increase reagent consumption. Soda ash and lime sodium silicate are examples of dispersants, while starch is used as a flocculant.